All right, let's talk about something we see every single day, but probably never think about: the humble brick. I mean, for thousands of years, this one simple object has been the building block of our cities, our homes, our entire history, really. It's so common we just walk right past it, but its story is absolutely fundamental to our civilization. And today, that story is getting a pretty fascinating new chapter. So here they are, side by side. On the left, you've got the classic, right? The champion we all recognize, that familiar red clay brick. And on the right, we have a modern challenger, this sleek gray brick made of something called fly ash. Now, they obviously look different. And trust me, they feel different. But as we're about to find out, the real difference is, well, they're in how they're made and how they perform. And that brings us right to the heart of it, the big question. You've got one brick with a legacy stretching all the way back to ancient civilizations, and the other? It's literally made from industrial waste, the leftovers from coal power plants. Seems like a pretty easy choice, doesn't it? Well, you might want to hold that thought, because the answer is probably not what you're expecting. Okay, so before we can really appreciate the new kid on the block, we have to take a closer look at the reigning champ. And it turns out, the classic clay brick isn't quite as perfect as it seems. It's got a few secrets hiding behind that familiar red face. You know, the simple truth is, making the bricks we've used for centuries, it comes at a price. And I'm not just talking about digging up clay from the ground. The real issue here is the massive, and I mean massive, amount of energy it takes to bake that clay into a hard, sturdy brick. And this is where the scale of the problem really hits you. Take a look at this number. To make just 1 million clay bricks, which sounds like a lot, but isn't in the grand scheme of construction, you have to burn about 200 tons of coal. And what does that do? It pumps a staggering 270 tons of CO2 straight into the atmosphere. Oof. And, well, we all know what that means, right? Those emissions are a huge contributor to the greenhouse gases warming our planet. So think about it. The very foundation of our homes and cities is directly tied to one of the biggest environmental challenges we face. It's kind of a big deal. But what if the solution was hiding in the most unlikely place? What if it actually came from the same industry that's creating a big part of the problem? Well, it's time to meet our unlikely hero, fly ash. So, what exactly is this stuff? Basically, fly ash is the superfine powder that's left over when you burn coal in a power plant. For the longest time, everyone just saw it as waste. You know, garbage. Something you just dump in a landfill and forget about. But here's where things get really clever. Some innovators had a kind of aha moment. They realized this waste was actually an incredibly valuable resource. This fine gray powder right here, it can be totally transformed from a landfill problem into a powerful building solution. And the way they do it is the real secret sauce. Its big environmental advantage. See, instead of being fired in a massive energy-guzzling kiln like a clay brick, the fly ash mixture is just pressed. It's put under high pressure in a machine and then left to cure. That's it. The sources actually call this an energy-free route, which means no giant ovens, no burning tons of coal, and, you guessed it, none of those 270 tons of CO2. Okay, so we've established it's way greener to make. That's great, but can it actually, be a good brick? Can something made from waste really compete with a classic that's been proven for thousands of years? Well, let's get into the performance showdown and look at the hard data. All right, it's time for the head-to-head, clay brick versus fly ash brick. We're going to look at everything from weight and strength to how well they actually keep your house comfortable. Let's start with the basics. First up, density. The fly ash brick is almost 3 times lighter. That's a huge difference. But the really critical number on this chart is thermal conductivity. Now, all that means is how good is it at stopping heat from moving through? And for this, a lower number is better. As you can see, the fly ash brick is way, way better. Now, you might be thinking, okay, it's lighter, so it's probably weaker, right? Nope. The research actually shows the exact opposite. This study from 2018 found that fly ash bricks are a whopping 33% stronger. So let's just recap. They're lighter, they're better insulators, and they're stronger. That's pretty impressive. And this chart right here, it just visualizes that insulation advantage perfectly. This is thermal resistance. It's basically the opposite of conductivity. It measures how well something stops heat. So here, a higher number is better. And while
you can see for yourself. The fly ash brick is the clear winner. Not even close.
So what does all this technical jargon actually mean for you in the real world? It's simple. Better insulation means your home stays cooler in the summer and warmer in the winter, all on its own. Your heating and your AC don't have to work nearly as hard, which means a more comfortable house and lower energy bills. Win-win. Here's just one more chart to really hammer this home. This is the U value, which is pretty much the flip side of resistance. It measures how much heat gets through the wall. So on this one, you want the number to be as low as possible. And once again, look at that difference. The fly ash brick just performs way better. So, the data is pretty clear, right? The Challenger, the brick made from waste, isn't just a greener alternative. In a lot of key areas, it's just a better brick. And that has some huge implications for how we think about building our future. So let's just zoom out and recap why this matters so much. First, you're turning industrial waste that would just sit in a landfill into a valuable resource. Second, you're saving a ton of energy and slashing CO2 emissions because you don't have to fire them in a kiln. And third, you end up with buildings that are literally stronger and better insulated, which can lead to lower energy bills for everyone. It is, like we said, a win-win-win. And look, this isn't just some pie-in-the-sky idea from a lab. This is happening right now, in the real world. This document shows that fly ash bricks are an official, certified building standard in places like India, a country that produces a ton of fly ash. So this technology isn't just theory, it's real, it's regulated, and it's already being used. So I guess the big takeaway here is that sometimes the biggest changes come from rethinking the most basic things we take for granted. Just that one simple choice, what kind of brick are we going to use, can have this massive ripple effect. It touches everything from our landfills and air quality to how strong our buildings are and how much we pay for our energy bills. It really proves that the foundation of a greener future might literally be built from the waste of our past. So the building blocks of our world are clearly changing. The only question left is, what will we choose to build our future with?